All right, welcome everyone to the February 8th SIG Node meeting. We have a couple items on the agenda. I think the first item we can talk through is the container D issue. Is the reporter here able to speak to the topic?
Yes, I'm happy to. Hello everyone, my name is Qiutong. I work in the GKE team. I want to share a finding of long-going container debug we have been investigated. Let me open that the issue link. Do you want me to share the screen, or you can open the link for me?
Let me make you a co-host, and then you'll be able to
screen. Okay.
I'm not seeing your name for some reason.
Qiutong Song.
Oh, there you are. Thank you.
Okay.
Don, are you able to make him a co-host? I right-click and I don't have the option to make him a co-host.
Dawn saying she's having some trouble.
There you go.
With audio.
All set now.
Oh, okay. Okay, cool. Let me open the window. Okay. Am I sharing the screen?
Yeah, it looks great now.
Okay, cool. This issue, the simpleton. Okay, let me restart. The simpleton is customer see the error message called fail to reserve container name when they use container D. This is specific to container D because the error message is returned by the container D CRI plugin. And they also see, when they see this message, the pods are usually stuck. They are not created successfully. And this issue can be back to like 2 years ago, but with the more adoption of Container D, we are seeing more customer reporting this problem. So it's got our attention, and we also prioritize solving this issue. And now we have a promising fix. And I want to share what is going on and what will happen next. So the issue is simple. When Kubernetes makes a create container call to the container runtime, if the first create container call takes more than 2 minutes, which is the default timeout, and then our kubelet will just retry more later. And in some cases, the first create container request in container D can hang for a long time, as long as like maybe 30 minutes that long. So in that case, the subsequent create container call will just fail fast because they are retrying on the same container name, and the container D CRI will just say, no, you're not to do this because the name is already reserved. It's just like that. So the problem is then why the first or the initial create container request takes that long. And from the issues we have seen so far, it's always associated with slow disk operations. The disk operations, like on GKE, it's a disk throttle, which means there are a lot of disk I/O at that time. But it can the disk I/O can come from a number of factors, like the maybe pulling images, maybe the customer's workload is disk I/O heavy, and yeah. So, and recently we realized a thing we can optimize in Containerd, which is to remove a necessary disk operation during the stack of create a container call, and it's just a, and in the Docker implementation, it has a similar kind of similar improvement or enhancement of that part, and we did the same thing or a similar thing in the Containerd, and after that we can see even during disk throttle cases, the create container request can return fast. So this is the patch or the fix we're doing for this problem, and the fix is already merged. It'll be available in 1.6 plus, and we also backported to 1.5.x. So that's the status. If you guys or any user are seeing this problem, yeah, please route them to this GitHub issue and try the new version with the patch. Also, I should state that there may be other factors contributing to this problem that is undiscovered, because like I mentioned, the disk operations can come from other parts, maybe pulling images. Yeah, any question?
Chutong, when we discussed earlier, I remember you mentioned that it's really difficult to reproduce this problem. Did later we find how to reproduce the problem? And also, it's possible we can add some regression tests?
Thank you for asking this. This is a great question. Yeah, I forgot to mention. I try to reproduce this. I try to find a setup or experiment that's showing like a Docker always create a pause faster than Containerd during disk throttle case, but I couldn't find it. Even today, I could not set up such an environment. If I add too much disk I/O, both are just stuck there. No one can proceed. If I add the less disk I/O, the result can be random. So I still didn't find the perfect balance point. So I'm hoping if because customer complain about this, and they have some workload. They may their special workload maybe maybe make it even easier to trigger this. So I already contact a lot of customers to ask them to help reproduce with their workload and the environment. Yeah. So now we don't have a good way to have a reproduce or add regression test. I will keep looking at this.
Thanks. Another question, actually, the follow-up question. So it is actually even Kubernetes receive this container DEC or fail to reserve a container name error, but actually the whole thing, if give some time, the whole thing will settle down, right? So the container, because the previous request will finished and give enough time, and then what's the real customer impact here? It's just take longer and you receive some error, and then better error handling actually can solve this problem. But what's the real customer impact?
Right. Yeah, I should also call out that if if you have if you set restart policy to always or on failure, the pod will be created eventually, given enough time. But so some customers use a restart policy failure, so then they will see failed pod. That's one case of customer impact. Another case is they are claiming when they use Docker, the pods create faster. So that's the impact. Yeah.
Okay.
They are stuck longer when they use containerd. It's a comparison.
Hi, this is Derek. I appreciate you bringing up more operational experience for these types of issues, given the move we're making in the SIG to finish the deprecation of Docker shim. I know, speaking from some of our experience at Red Hat, we have tackled similar issues on disk I/O contention. So I know Peter Hunt and Mernal had explored this as well for cryo. I don't know if you want to talk through if you've seen similar impacts, and did you do similar remediations?
Peter, go for it. You're the expert.
Hey, yeah. So we did. Yeah, we have actually seen a bunch of these. There's also a class of issues we find when SE Linux is enabled, because for every new SE Linux, every new container, if the SE Linux label is chosen by cryo, then the rootfs is relabeled, and that can take a long time. Or not the rootfs, the volumes get relabeled so that the pod has access to them. So we actually implemented some workarounds in cryo to save the work that we did in an original request and like kind of stall the kubelet polling on this to work around this issue. There's a couple of different KubeCon talks that we've given that kind of describe this process and what has to be done.
Awesome. Well, thanks for sharing that, Peter, and thanks for bringing up the related BZs, because I think as a community, we all get better when we figure out how to mitigate these issues when they're found and at the right layers of the stack. So is there anything else you wanted to raise on this particular topic?
Okay,
awesome.
Yeah. Thank you,
Well,
guys.
thanks so much. I think the next topic is, I think Aji, you raised this. I don't know if he's here.
You mean Abdullah?
Yep.
Yeah. Yeah, I just wanted to bring to your attention this issue. Like it's an old new issue, the problem with the scheduler and kubelet being out of sync sometimes on how much resources are available in the node. So recently there has been a change in, I think, what kubelet considers as available resources for terminated pods. So in the past, once a pod is marked as terminated, like whether it's like failed or completed, the resources are assumed to be available. Like the scheduler assumes that those resources are available, and so it can schedule. Like they remove these pods from being assumed as on the node. The change was that in kubelet admission, those resources are still being considered as used until the pod itself completely terminates. And so basically, we update the pod status to finished or completed, or like basically terminated, before we actually assume that, before we actually make its resources available for other pods. So that change was actually patched back. There is a reason for the change. I think Clayton made that change. It solves another problem, but it did cause issues related to, again, like rest conditions with the scheduler. And the reason I'm bringing this to the SIG, again, like first is to make you aware that this is an issue. The second is, like, in retrospect, like these things related to admission should be probably coordinated with SIG scheduling, because like again, we want to be on the same page, the kubelet and the scheduler, and what is available on the node, what is not. And the third is to discuss like how should the scheduler treat terminated pods? When should it assume that the resources of terminated pods are available for other pods? So yeah, let me know if you have any questions, or if you would like to just look at the issue and comment on it. I didn't see any of the SIG leads commenting directly on the issue, other than Clayton. So I just want to make sure that you're aware of that one.
We aware this one. Even
Okay.
design, in the design phase, we talk about this. There always have the asynchronous issues. Like so this is just one of the symptoms, right? So the terminated, how we are going to, because the master side express the desired status. Master side, but we reclaim of those resources take times. Those kind of things from day one, by design, distributed computing always have this problem. Disk will be even worse, right? So when you reclaim the disk space, you say, oh, I'm evict this part and take that resource, but delete those kind of things and remove those related logs and disk usage. It take really long time. So we know those things. So this is why at the end, you need to actuator to move the system into the desired state, actually is the kubelet. So we're always talking about the kubelet. In reality, if you really think about it, for the fine grain of the scheduling decision, actually it's the kernel. So, but on a high level for cluster management, there's the scheduler, which is the cluster level of the scheduling. But then there's the Kubernetes as the node level, and also maybe it's some other component, Kubernetes or coordinate. There's the maybe have some like the plugin, resource management plugin. We are doing those kind of things. So those kind of problem always being there. It is the only problem we need to be careful when we design those things. It is those should be real. We don't want to create off the situation and scheduler make decision and send it to the node reject, and scheduler send the same request back to the same node and reject. So those kind of is by the problem. But sometimes there are some such things happen asynchronous. We need to keep that into to certain threshold, but it is acceptable. This kind of problem can be gone.
No, but like here in this case, it should be easy to solve because kubelet will be updating the pod status. It could update it only after it considers that these resources are available for scheduling. So why is kubelet declaring that the pod terminated while it is still not making its resources available for scheduling? So what the scheduler does right now is basically, once it receives an update that a specific pod that was assigned to node X is terminated, it's going to assume, okay, this pod does not hold any resources in the node. I can reuse those resources, schedule another one. So kubelet is getting ahead of itself by declaring that the pod is terminated while still holding some resources reserved for that terminated pod. And so the ask here is to have an easy to consume pod status by the scheduler to know that kubelet has released all these resources, so it's available for the scheduler to consider them for future pods.
So just I think I have to check myself a little closer, but I would be terminated pods still hold resources on a kubelet, but the resources they hold aren't necessarily what we would think. They can still hold disk, and they can still hold, their logs are still present. So the only thing that catches me by surprise on this particular issue report is that the thing that's failing is saying that it's holding CPU. And so exactly. I agree that terminated pods shouldn't be holding CPU, but terminated pods still have their resources present on the node for later inspection. Similar to the artifacts that Dawn had referenced. I was trying to think if there was a situation where a terminated pod could be having its CPU.
So
held, but it's not coming to mind. But I guess what I would want to do is just check to see if the add a CPU filter check here or not is filtering out terminated pods because they're not actually holding CPU, but they could definitely be holding disk. And
Yeah, is it actually terminated pods or terminating pods? Because the Clayton's summary was terminating, which makes sense.
we are, let me see.
Yeah, terminating might hold the CPU. If terminated, then CPU, yeah, if it still hold the CPU, then must be some bugs.
So we filter out pods with a phase, status of phase equals succeeded or failed.
Ah, and so that you probably also need to check whether it's actually completed. If the phase is just failed or whatever, it can still be cleaning up because the priority there is reporting that status back while we do that cleanup, especially if you have like a CRI that's being particularly slow.
So Clayton is suggesting that we, let me see, the report status is not terminated. Yeah, and we need to check to have terminated status. So the scheduler needs to check also the status of all the containers. And to me, this is like I don't know if the scheduler should be looking at the termination status of the containers. Maybe, I don't know, maybe yes.
So succeeded and failed should be terminal pod phases.
Now they happen early, partially as performance optimization for external systems, I think.
I think that I do not, if you look at the history, many times I complain, scheduler is not usage a while scheduler. Only look at the request and the machine capacity, not look at the real usage. So, so that's make this kind of the, even we look at the usage, you still have the, because the async raise some of the things, but will be way better than today. Because today we didn't look at that, we never try to attempt to consider reclaim. Sometimes reclaim resource take a really long time, and this problem. At the earlier, I remember the first KubeCon, the small KubeCon, and I raised my this is one of my wish list. Many things happen, but this one particularly is never happen, and usage a while scheduler.
Right, but the latest change made this problem even worse. Like there was a regression because we even started to make the pod phase succeed or fail even much earlier than it was at least before. And so we're even increasing the window for this race between the kubelet and the scheduler.
Technically, it made technically the previous behavior was an incorrect bug.
Yeah.
That just happens to have negative effects across different things because that's how Kubernetes works. There are probably things that could be done to fix that, but none of them are obvious because that part of the code base right now, anytime someone touches it, someone complains about something breaking somewhere. And if there isn't a test for behavior you're expecting, it can't be maintained.
So what I suggest here is if you can please take a look at the bug and suggest what status we should look at on the pod for the scheduler to have the smallest chance of getting into this race condition. What status should we look at to consider that the pod has freed its resources?
Abdul, I guess what I was suggesting is I don't think there's a scheduler bug here. The more likely thing is that the list of active pods that's being evaluated on the kubelet when doing its emission check is has a bug that says that CPU is still being held when it's terminated. So we need to look into that a little closer, but that active pods list or whatever that list is that's getting propagated to the admission handler in the kubelet, it might need to filter out resources that can't be claimed when all containers are stopped, in this case, CPU. whereas disk, it might be, we might need to make a different decision on. So if the key thing is the out of CPU thing, I think there's likely a bug that we could chase down on the kubelet side, so that its emission check is not going to run into this.
Right, and my concern is that like I saw 2 or 3 issues open related to this recently in open source, and within in GKE internally, we've got multiple reports related to this in 121 and 122, because this was backported, and that's my worry. Like right now, we don't have too many clusters in these releases, but once they become the majority of our fleet, I'm pretty sure we're gonna get a lot of like bugs related to this.
Yeah.
I mean, at the end of the day, it's like you can tell them, okay, this is just an out of CPU pod. It's okay. The deployment we're gonna, or like I said, we're gonna create a replacement pod. But when they list available pods in the cluster and they see all these out of CPU rejected pods, it's gonna always scare them.
One question I want to follow up, since you mentioned GKE. Looks like the GKE have this problem. Did the GKE enable any like the CPU related overcommitted feature? We don't, right? So if we don't, and then yeah, there's must be some bugs. If we do, then I'm not sure. Then we need.
I don't think we do.
Okay.
Okay, well, thanks, Abdul. And I can appreciate that if you're running a lot of short-lived pods in like a batch mode on a highly packed worker, you could be hitting this. So we'll have to take a look. Anything else we want to raise on this issue?
I have a question. Daniel, you mentioned that this is a fix actually we want. Do you mind to share that fix related to this behavior change? So
if the PR that caused it is the one that I think it is, we had a bunch of race conditions in the like pod lifecycle management that meant some stuff wouldn't be tracked properly and some statuses wouldn't be propagated in like the correct way. I don't remember exactly the bugs that Clayton was fixing though.
And you can find you can find from our meeting notes actually the Clayton. Cool. We talk about that a couple times, and then even like follow up the risk condition and how to fix those leakages in the SIG Node. We've been talking about a couple times.
And so some of the work around fixing that has raised a bunch of complicated issues. Some of those are the previous behavior was incorrect, and some of those are, well, we don't have enough testing, and so there are some regressions, and it can be hard to figure out which is which to begin with, because the behavior of the kubelet isn't actually documented, and there isn't like a test spec that exists anywhere that correctly covers most of the kubelet. Which gets complicated.
I see. Okay, thank you. I will read the notes and find it. Thanks.
Okay.
Does anyone actually have time to look into this week? Cool. I'll try and take a look if nobody else can get to it.
Yeah, it'd be great to you. Thank you.
No worries. It is less tedious than spending my week refactoring Container Manager to be testable.
Okay. I guess the last topic on today's agenda is Deep. Do you want to talk through your item?
Yep. Let's see. Can I share my screen? Awesome. Thanks. So let's see. All right. So for a quick background, one of the things we discussed a little while back in 1.23 in SIG Node briefly was this concept of runtime assisted mounting of volumes. So the idea was, can can it be possible for kubelet to basically defer certain file system mounting activities to the to a OCI runtime rather than have the volumes be mounted by the default CSI plugin in a host environment if the runtime is capable of doing such things. So the key scenario is basically in the left, which is kind of like Kata micro VM style scenarios, where the micro VM environment might already have the file system loaded in the guest kernel, and it can avoid a lot of this Vortio FS based file system mounts that's pointed out in the left of this diagram. So essentially, the model that would be ideal is to kind of get to something like this, which is essentially having a block layer, which is a pass through between the Kata containers and the pods running within, say, a micro VM environment like Kata and the underlying disks. So we worked on this with SIG storage quite a bit, iterated through a few designs during the last 1.23 cycle. And one of the things that came up is, would it be possible for kubelet to have a set of APIs through which it can directly communicate with the end OCI runtime, like Kata in this case, for example. So essentially, this API would be very similar to that of what the CSI Node plugin APIs are today. In fact, each of the APIs, if you look, are almost identical. Like in CSI, we have node publish volume. Similarly, this API would have, say, runtime publish volume. So in CSI, you have node get volume stats. It'll have a runtime get volume stats. Same with expand volume. And I just gave it a name, calling it crust APIs for now, like container runtime storage APIs, but the naming is always hard and can be debated. The next steps that were suggested from these discussions in SIG storage was, of course, get SIG Node's opinion on this if there are any major objections, and eventually go up to SIG Arch and kind of get approval for something like this. So my goal here was to sort of just present this idea. In summary, in this model, we expect no changes in the CRI layer, but instead kind of have this driven through these new crust APIs where the kubelet talks directly to the final runtime. Essentially, we will need these new APIs and the ultimate handler to, of course, implement the APIs and present this functionality.
That's a good question.
So we have a KEP going with this with a lot more details. So it will be great to get feedback. But yeah, that's
generally,
all.
like we had a goal of making runtime class kind of opaque to the kubelet, and just make sure I understand the high level here is saying the kubelet would be runtime class specific aware, and then when a pod is presented saying I'm going to have a Kata sandbox, you want the lifecycle of the kubelet to work differently?
Essentially, like in the KEP, what we came up with is the runtime class just surfacing like a domain socket through which kubelet can essentially ask the runtime for, hey, what are your capabilities? Do you support this new runtime API? And if so, invoke these APIs on the runtime.
And it would do this on a per pod basis?
On a per pod basis, correct. So essentially, as the pod comes up, before sandbox creation, get the capabilities. Right after the sandbox gets created, it needs to call runtime publish volume. The main things this would do is do things like applying the FS group settings, applying any SE Linux labels, and surface any subpaths. These are the special things that Kubernetes does today if the volume is already mounted by a CSI plugin. And then during the lifetime of the pod, potentially handle get volume stats and expand volume as those come in through the kubelet volume manager.
Wouldn't it make sense to just like make the CRI runtime handle it, so then kubelet doesn't have like runtime specific code or knowledge?
We did explore that. The main thing was, I think, like there was a bit of hesitancy around expanding CRI to do it, and it can all be achieved without involving the CRI runtime and the CRI APIs. If that is the preferred path for SIG Node, definitely willing to explore that model. But like one of the other things is also the APIs for this needs to sort of be as close as possible to CSI, the CSI node APIs. And that was kind of one of the reasons why we wanted to have this new set and have it basically just mirror CSI node APIs without having to pollute the CSI APIs with runtime specific stuff.
And then if all this work was done, what is the actual benefit at the end?
The main benefit is we want the pods running within Kata sandbox to be able to use a direct, the block interface between the pods and the underlying disks, as opposed to the current model, which is using a projected file system interface, which is VirtIO-FS, between the underlying device and the pod. So with the current model, there are quite a few disadvantages with VirtIO-FS, some of them being, performance, the other being security overall. And with the direct block pass-through, with the mount happening within the sandbox, those concerns are alleviated to a large extent.
Okay, so like if I was to summarize this as the Kata community no longer has to work with VirtIO or VirtFS by virtue of the kubelet taking on sandboxing specific challenges, like that's the give and take here. Is there
Exactly.
is there a performance benefit at the end, or?
Correct. So performance and security are the key benefits with this approach. So what we have also found is a couple of cloud vendors like Alibaba and I think another one. They have been introducing this model with a customized CSI plugin and very customized Kata, kind of doing an off-band handshake, which is very similar to what we're proposing here. But basically, that model very closely ties the CSI plugins to the runtime, basically circumventing kubelet in this picture. And one of the problems with that model is we cannot handle a lot of the features that are surfaced today, like subpaths, FS group application, and SLinux. Whereas with this model, we can handle those.
I think what gives me pause when I first look at this and I have to read your enhancement in more depth is you kind of have a special code path for a particular class of pod and isolation technique. And I think we're trying hard not to do that. It's cognitively overloading. And I think, is it possible to present a path that says this is how these new invocations would work independent of the runtime choice, so that like no matter what the runtime class, the CRI and kubelet interaction sequence was always the same, versus making the kubelet have to be it's basically reintroducing like a strong coupling we've been trying to get away from. And so hopefully you could appreciate that that is cognitively difficult to then maintain.
Mm-hmm.
I agree with Derek. We try very hard, no matter it's the CSI, CRI, actually it is try to make the core Kubernetes, it is more generic. So not to, and also we have some like all the other design is like the modernize those kind of the different particularly use cases. Basically just want to Kubernetes more generic. Yeah. to handle all the cases. This is, and because you earlier heard this pod lifecycle, container lifecycle is so complicated already.
Mhm.
Yeah.
And just there was some hesitancy expressed that we didn't want to change the CRI. I don't think that that's true. I think we're open to making updates, and we have. And so if you wanted to take a look at this from like a more universal CRI change, I think that might be a different perspective to take rather than like a side-by-side model that's being presented here.
Got it. Yeah, that's reasonable. Yeah, some of the things I didn't find it right now is this concept of, I guess, querying for capabilities, like a wide set of capabilities that that CSI kind of supports. But yeah, if that's a path, I can definitely explore that, update the cap, and come back with how that model would look like.
Okay, that sounds great, Deep. I think even this release, we merged some enhancements to update the CRI for things like container checkpointing and stuff. So we're trying to make it that you can have a section to maybe do more exploratory innovation in. And so, yeah, I don't want you to walk away from here thinking that we never want to change the CRI anyway. Like that's not our goal. Our goal is to not make the kubelet split more split brain than it needs to be, I guess. So, all right. Well, thank you, Deep. Any other discussion that we want to raise on this topic?
I had a quick question. Just for my understanding, is the published volume, is that to push data down into your Kata sandbox, or is that just to define a volume?
So publish volume is just a fancy storage term for mounting. It's essentially just like mounting the file system given a volume device.
Okay.
So essentially it boils down to it's the mount syscall. Yeah.
I'm wondering, like, how are you handling with this service account tokens or mounted, mounted secrets or config maps? Where's that path?
So if it's a ephemeral inline volume that's not backed by a block device, then things would kind of fall back to the what IFS space thing, because there's not much of a performance or security surface area associated with it. This is primarily for large volume backed, large block device backed volume scenarios. So if you have,
Gotcha.
say, EBS volume, then
So you're still sharing a file system with the sandbox at that point?
correct.
Okay.
Okay, thanks a lot for the feedback. So I guess I'll try to explore if we can plumb this through CRI in some form and get back. Thanks.
Thank you, Deep. With that, I think that's the end of today's agenda. We're back at 12 minutes of time, and thanks for those who joined and participated. All the best.